we can find that the series is divergent. We say right. So the third thing is that if L is equals to 1, then the series is inconclusive, or the series may be divergent, or it may be divergent, it may be conditional, convergent, or it may be absolutely convergent. This is what it means to say something is inconclusive. It means that it is inconclusive. Inconclusive. I want to say that something is inconclusive. This is what we mean. Something that can be divergent, can be conditionally convergent, or can be absolutely convergent. Now, we can come to discuss the part of what do we mean when we say something is absolutely convergent, and what do we mean when we say that something is conditionally convergent, right? So I think first we can focus on the part of the absolutely convergent. When we say that something is absolutely convergent, I'm saying that if I take a series A of n, right, then I apply the absolute value and I find that it is convergent. That means that that series is absolutely convergent. You see that? So let me define this. Let me actually define this here. Come here. I can talk about absolutely. So when I say that a series is, I can say that a series AN is called absolutely convergent if I find that the absolute, the summation, summation of AN with its absolute is convergent. You say right. Then what do I mean when I say that something is conditionally convergent? What do I mean when I say that something is conditionally convergent? Then if I take a series, that's right. If a series, or let me say this, if a series if a series is convergent and the one with the absolute value, let's say I check this series first and I find that it is convergent. Then when I check it with an absolute value, I find that it is divergent. Find that when I check it with an absolute value, it is convergent. It is divergent. When I check it with an absolute value, I find that it is divergent. When I check it with this original one, it is convergent. With its absolute value, it is divergent. then we can call this, we call the series, this series, that it is conditionally convergent. You see, right? We call that series conditionally convergent because when I check the original series, I find that it is convergent. But when I check the series with an absolute value, I find that it is divergent, and then this will call it conditionally convergent. And then for this, we can say that for the conditional one, let me write NB. So I can say that if this series is convergent, is absolutely convergent, then it is also convergent. This means that when it is absolutely convergent, it means that that series is convergent because it satisfies two conditions. The original series converges, also the absolute value converges. So it is absolutely convergent. You see, right? So we can keep this in mind. So after mentioning that a series is absolutely convergent, you must also specify that hence the series is convergent. You see, right? So that's what we can look at. Then let's go back to root test, and then we do some questions based on root test. And then on root test, last time we once discussed this, that the limit as n approaches infinity of n to the 1 over n, this is equals to 1. You see, right? So don't be shocked. This you must just know it. Don't be shocked when you come across this. Then we apply some limit to that, and then we get 1. And then first we are asked this, or to show this, or to prove this. We can try to prove this so everyone can see, because we discussed this on last week. Was it on Thursday, the cross night, right? Yeah, we discussed this week, Thursday. And then first what I do, right, if I have this question, the limit as n approaches infinity of n to the 1 over n, first what I need to do is check the form. The form of this is infinity to the exponent 0. And remember, a L'Hopital rule only has two forms. Only has two forms. The first form, 0 over 0. Second form is infinity over infinity. Whatever you get should be changed to this form. You see, right? So it means that when we see this now, the idea should be we should come and introduce something to drop the exponent. Whenever we want to drop the exponent, we introduce ln. You see, right? And ln goes with e. So I'm going to introduce e first, then I introduce ln, I drop the 1 over n. You see, right? Then this will be, now I can have this, the limit as n approaches infinity of ln n over n. When now I check the form of this, the form there is infinity over infinite. You see, now I changed it to a L'Hopital rule. You see, right now. Then this would be, if I derive the, now I must introduce, when I derive, you must introduce the derivative to show that you are deriving. This is with respect to n. Ln of n, d over d, n of n. This will be e to the limit as n approaches infinity of 1 over n divided by 1. What is the limit of 1 over n? Is 0. And this will be what? 1. You see, right? We have proven that. So also now we know that the limit as n approaches infinity of 1 over n, this is 0. We know this from what's this limits at infinity, right? So now we can solve these questions since we know what that means. Now they say we should determine if the following series is convergent or divergent. You see, right? This would mean if we have this 3 to the 1 plus 2n, what we should do first is we come and say c will be equal to the limit. So first I can point out an. An is n to the n over 1 plus 2n. So I find the limit of this. Remember that I said that this is like this, the absolute value of an to the 1 over n. So it's much simpler if you put it like this. This will be the absolute value of the limit of the absolute value of n to the n over 1 plus 2n to the 1 over n. Then I apply that. Here I will have n on n over n cancels that. That cancels that n. And then here I will have 3 to the 1 over n plus 2. You see, right? And then this will be the limit as n approaches infinity. So what I can do here is I can now try to find the limit here. You see, right? So when I check, if I try to apply this on the denominator, on the numerator I'll get infinity. Here I get 3 to the 0 plus 2, which this would give me infinity. And remember, this said what? The rules said that if c is less than L, you're not less than L, I wanted to say less than 1. If c is less than 1, the series is absolutely convergent and hence convergent. But if it's greater than 1, the absolute is A. So this one also means that this can be equal to infinity. You see, right? If c is equal to infinity, did I say earlier? Yeah, c. But you can still use L. You can use L or C. It's up to you. So if c is infinity or it's greater than 1, we find that that is divergent. And then I can come and say, that therefore, also, by the root test, the series is divergent. You see, right? By the root test, this series is it's just divergent. Then I come to the second one. The second one I'm given, that n starting from 0 of 5n minus 3. This is 3n to the third over 7n to the third plus 2 to the n. Then we realize that our an is here 5n minus 3n to the third over 7n to the third plus 2 to the n. That means that we can find the limit, which is c as n approaches infinity, of, I put this all over 7 n to the third plus 2 to the n absolute value of 1 over n, which this is equals to, this will be equals to the limit as n approaches infinity of the absolute value of 5n minus 3n to the third all over 7n to the third plus 2. When I apply the limit here, I'm going to get the absolute value of minus 3 over 7, because these are the ones with the highest degree. You see, right? The other ones will give us 0. If I fix out n to the third, then this will be 3 over 7. So my question is 3 over 7 less than 1? Yes. You see, right? This is less than 1. So let me just come. Since that 7 over 3 is less than 1, now we can come and deduce and say, so by the root test, we can come and say that by the root test, the series is absolutely convergent and hence converges. Is that right? This series is absolutely convergence and hence it converges. So now we can come and look at the other one. So any question? Make sure if you ask a question, you open your mic, because if you ask it through this the chat box, I won't see. So there's no question, right? All right. So yes.
By the root test, are we always supposed to raise everything that we're given to the exponent 1 over n?
Yeah.
Okay.
Yeah. And then now we're given this. We have, then we see that our an is equals to minus 12 to the n over n. So it means that we must find c, which is the limit as n approaches infinity of the absolute value of minus 12 to the n over n. I'm sure that you can see that every day the information is getting piled up, right? So if you don't practice after class, you're being left behind. And if you try to practice everything at once, that's where the problem begins, right? So you'll have a problem. So you should make sure that you practice while there's still time. So here we're left with minus 12. The n will cancel out. Then here we're left with n to the 1 over n. If I distribute that, then, but we know this. We know that this will give us 12 over n to the 1 over n. And if I apply the limit here, I'm going to get 12 over 1. Because this one we know that it's 1. Alright, now. And this is 12. And 12, I didn't, where is this limit? I'm going to get 12 over 1 and 12 is greater than 1. You see, right? So when it's greater than 1, we know that the series will diverge. So by the root test, the series is divergent. You see, right? So I'm sure you see where that one you can apply it somewhere. Did you guys do the proof of root test? Did you do the proof of root test? Alright, I'll take it as no, since there's no solution or no answer to that. So yeah, I think now we can move to the ratio test. Alright. And then when we are at the ratio test, when we come to a ratio test, when we come to ratio, test, we remember from it's either from SMTH 012 or SMTB 000. We agree, right? This is coming from mathematical induction, that chapter 3. I think it's your chapter 3. Then we know that from factorials, we have factorials, that we know that n factorial can be expanded to be n minus 1, n minus 2, up until we get to 1. Then we stop. As you see right now. So this will occur if n is greater or equals 1. You know that if they didn't tell you anything, just assume that n is greater than equals or greater than or is an element of a natural number. And we know that 0 factorial is equals to 1. This happens by definition. You see, right? So now it comes again that 1 factorial is equals to 1, 2 factorial is equals to 2 by 1, 3 factorial is equals to 3 by 2 by 1. From this, we can deduce that we can have this. If I have n plus 1 factorial, I can get n plus 1 n factorial. Or n plus 1 n minus 1 factorial, and so on. You see, right? Or I can get this up until we get to you see, right, up until we get to 1. So we can reduce this up until the end. So now the idea comes in to say that if now I'm given 2n factorial, I can get 2n minus 1. You say, right, 2n minus 2. If I want to stop, I can stop here. Or I can just proceed up until 1. You see, right? Then I stop. But wherever, if I'm not stopping at 1, wherever I stop, I should put a factorial. We agree, right? So that's what we should keep in mind for the time being. So if we have this, now we can apply the ratio test. Now also note this, 2 n factorial is not equals to 2n factorial. This is a 2 n minus 1 n minus 2. You see, right? And this we know that it's 2n minus 1 to n minus 2 factorial. We know that difference, right? So now let's suppose if we suppose we have the series. So we can define this series. Similarly, we can say C is equal to the limit as n approaches infinity, the absolute value of an plus 1 over an. You see, right? Then we say this. Now, this, if we want to discuss the convergence, we can say that if L, the convergence of this is the same thing as the run of root test. Yeah, I'm talking about C, right? If C is less than 1, the series is absolutely convergent, and hence convergent. If something is absolutely convergent, it has been thoroughly confirmed that it is convergent, right? So we agree with it. So if C is greater than 1, the series is divergent, or where C is equal to infinite. If C is equal to 1, the series is inconclusive. You know now what does it mean when we say something is inconclusive, right? We say that it can either be divergent, conditional divergent, or absolutely convergent. Yeah, conventionally convergent, absolutely convergent, or it can be divergent. You say, right? Now, we come to focus on some problems there. We come to say that if we have this question, they say we should determine. So we're gonna do questions here and then we close, right? I'm supposed to submit something. Determine if the following series is divergent or convergent. So if we want to determine if this is convergent or divergent, first we pinpoint our an. You see, right? Then we find the limit n approaches infinity, the absolute value of an plus 1 over an. Then this will be absolute value of n plus 1 infinity over 5 to the n plus 1 divided by n factorial over 5 to the n. And this will be equal to the limit as n approaches infinity of n plus 1 factorial over 5 to the n 5 to the 1 times 5 to the n over n factorial. And then 5 to the n, we realize it cancels out, right? I don't have to show that it cancels out. I can just omit it on the next line. Then we know that n plus 1 factorial can be reduced to n plus 1 n factorial. So this will be all over 5 times n factorial. So this will be, the n factorial will cancel out. We'll be left with n plus 1 over 5. Do you agree on that? Any question? So I think if we agree on that, then we can easily look at what type of a limit is this. What are we getting here? Infinity, right? So this is greater than 1. So the series is going to diverge. Do you agree? The series is I can say so by the root test. Is it the root, the ratio, right? By the ratio test, the series is divergent. So now we come to another question. We have B. Now on B we have this. We have a summation of n equals 1 infinity 9 to the n over minus 2 to the n plus 1 n. First we pinpoint our an. We see right. Then now we apply the limit. The limit as n approaches infinity, the absolute value of an plus 1 over an. This will be equal to the limit as n approaches infinity over 9 to the n plus 1 over minus 2 to the n plus 1 n plus 1. Right, divide by, and then we have that. So this will be equal to the limit as n approaches infinity of 9 and 9 over minus 2 n plus 1 times minus 2 n plus 1 times minus 2 n plus 1 n over 9 to the n. 9 to the n cancels out, and that minus 2 to the n plus 1 cancels out also. So I'm left with 9n here. Down here I'm left with minus 2 n plus 1. You see right? Then this will be the limit as n approaches infinity over 9 n over 2n plus 2. So the limit of this will give us 9 over 2. You see right? Then when we get 9 over 2, this is greater than 1. We realize that so
can you please go up a bit?
by the ratio test, the series diverges or is divergent. We say right. So I can give you problems now. I'll put problems here at the end. Then let me see. I see problems. Then now I see a ratio test. Then I have this cos 1, 3 1 minus 2n over n squared plus 1, 2. Make sure you complete this before the next class, right? Try to work overloading your. Today, you can try to skip church if you see that you have a lot to cover. So if you know they can't survive with you their church today, they must try. Yeah, then you can do so let me give you trust me, if you can do 5 problems per topic, you're fine. So I'll give you this. And then now I give you the root test one. And then I can give you the root test. For root test, I'll just give you 3 because these ones are not that difficult, right? Root test. Even if you know that you're not going to write that test on Wednesday, make sure you write this. It will be much simpler for you when you're preparing for the exam. Yeah, for the root test, I think 3 are fine. Then, absolute convergent, yeah, alternating series.
Dabatalo, could you please scroll up just a bit?
This is the highest that could go. You mean the previous slide?
Yeah.
Alright. You're copying these problems?
Only number 3.
Yeah, but I'll send you this PDF in the group now.
Okay, sure, sir.
Yeah. And then for alternating series, can give you 5 here. Yeah, after tomorrow's class, we're gonna do the same thing. If you're left behind, you'll have a problem in catching up. Make sure that you study this today. If you haven't, if you were relaxed. And then we have number 4. Then the last one. Yeah. And then the alternate answer is we look at comparison test. For the comparison test, summation n equals 1 over n squared plus 1 squared 2. Yeah, I'll be available, guys. If you want to ask about any question here in the group, you ask. And then if I have to make this, if I have to make a video explaining, I'll make it. Just make sure you ask in the group the best way to be answered so that others can see, right? Because if you ask privately, I'll be assisting you only alone, you see, which is then people come and ask the same problem. Don't be afraid to ask in the group whether you're going to write or not. Again, we're all preparing for exam, so yeah. And then come to limit comparison test. This will be the summation. N equals 1 into the third plus 7 all over n to the 4 sin squared n 2 with the summation was 0 2 to the n sin squared 5n all over 4 to the n plus cos squared n. Trust me, once you finish writing these problems, you're ready. N equals 3 e to the minus n over n squared plus 2n. Then number 4, n equals 1 n squared minus n over z plus 9. Number 5, we have a summation infinity n equals 1, the root of 2n squared plus 4n plus 1 over n to the 3 plus 9. Right. And then, yeah, this information is a lot. And I know someone is planning to study this a day before. All of this, 6 chapters. If we have integral test, now when we come to integral test, we have the summation n equals 1 over n to the pi 2 summation of infinity n equals 0 2 over 3 plus 5n. So you'll send me the proofs that you did in class, right? So we can look at some. Then I explain to you how are they done. So I think if you can be able to understand a proof, you can write it. Something that you understand, you won't forget, right? So cramming won't help us. Yeah, so I think we can look at some. Yeah, I think these ones are fine. Yeah, these are fine.